This video is an introduction to recurrence relations. The terms in a sequence may be defined by a recurrence relation, and a recurrence relation is a formula that gives the connection between two consecutive terms in a sequence. So a linear recurrence relation is a sequence defined by un plus 1 equals a un plus b, and a cannot be equal to 0. And the consecutive terms are usually labelled as un plus 1, that's the next term in the sequence after un. Or we can write the sequence as un equals a un minus 1 plus b. And again, this time un minus 1 is the term in front of un, but they are still consecutive terms. So we want to make a note here that un and un plus 1 are consecutive terms, and the starting value is usually denoted by u0. So in this example, Auntie Betty lives on a farm infested with bunnies. She decides that she's had enough of them eating her crops and has decided to start an eradication program. She estimates that there are initially 2,000 bunnies, so that's our start value, so our u0. During each month, she aims to exterminate 80% of the rabbits present, but bunnies being bunnies, each month another 100 invade Auntie Betty's farm. So we want to write a recurrence relation for the number of bunnies present at the start of each month. Now the question says that we're exterminating 80% of the rabbits present. So that means that the next term is going to be 80% less. So that means that if we take that 80% away, we're going to be left with 20%. So the next term, there will be 20% remaining. Then we also have to remember that another 100 are invading Auntie Betty's farm each month. So the next term in our sequence is going to be the current term multiplied by 20%, and then we're going to add on the extra bunnies. So un plus 1 is going to equal 0.2 un, and then we're going to add on 100. Now we need to specify our start value for this recurrence relation. And if we go back to the question, it states that there are initially 2,000 bunnies. So our start value, u0, is going to equal 2,000. So now that we've set up our recurrence relation, we can work out how many bunnies will remain after 4 months. The recurrence relation was un plus 1 equals 0.2 un plus 100. And our start value, u0, was 2,000. So we can substitute that into our recurrence relation to work out after 1 month. So u1 is going to equal 0.2 multiplied by u0 plus 100. We're going to substitute in our u0 equals 2,000. So that's going to give us 0.2 times 2,000 plus 100, and remembering to use BODMAS, that gives us an answer of 500. So after 2 months, we can then say that u2 is going to equal 0.2 times u1. So these are still consecutive terms, plus 100. And we're going to do 0.2 times 500 plus 100. And that gives us a number of 200 bunnies after 2 months. After 3 months, we're going to work out what u3 is, and that's going to be our 0.2 multiplied by u2, which was 200 plus 100, and that means that after 3 months there's going to be 140 bunnies left, and after 4 months, which is what we're being asked for in the question, u4 is going to equal 0.2 multiplied by 140 plus 100, giving us 128 bunnies remaining after 4 months. So in this example, a sequence is defined by the recurrence relation un plus 1 equals 0.7 un plus 5, where u0 equals 6. And we want to calculate the value of u3 and find the smallest value of n from which un is greater than 16. So we have our start value and we have our recurrence relation, and so we can work out consecutive terms in our sequence by substitution. So the first part of the question asks us to calculate the value of u3. And so u1 is going to equal 0.7 multiplied by u0 plus 5. And we know that u0 equals 6. So we can substitute that value in to work out the first term in our sequence. So u1 is going to equal 0.7 multiplied by 6 plus 5. And that gives us a total of 9.2. The second value, u2, is going to be 0.7 multiplied by the 9.2 for u1 plus 5. And so the second term in our sequence is 11.44. And the value of u3, which is what the question is asking for, is 0.7 times 11.44 plus 5. And that's going to equal 13.008. Now the second part of the question asks us to find the smallest value of n for un to be greater than 16. So we can work out the next terms in our sequence, and we're going to work out the terms until the value is greater than 16. So u4 equals 0.7 times 13.008 plus the 5 gives us 14.1056. u5 is going to be 0.7 times 14.1056 plus 5, giving us a value of 14.87392, which is still less than 16. So we need to look at u6. So that's 0.7 times u5, which gives us a value of 15.411744. Still less than 16, so we need to look at u7. And u7 is 15.7882208. Still less than 16, so we need to evaluate for u8 by multiplying u7 by 0.7 and adding on 5, and u8 is 16.051756, which is greater than 16. So that means that it's when n equals 8 that u8 is greater than 16. So the smallest value of n for which un is greater than 16 is when n equals 8.